Hello, everybody. Today we are going to talk about 9.2b, translation and reflection of log function. So first, let me go to the PowerPoint. Okay, as you see, so if you see the original function is f of x equal to log 2x, the base is 2. Now, if you see the g of x equal to log 2 negative x, in the parentheses, you have a minus in front of x. We learned in the log function, in the parentheses, any value cannot be negative or 0, right? So we should remember this. This cannot be 0 or negative. It should be positive. Then what happened to the graph? Let's see. And h of x is, negative is outside of log function, which means you multiply negative to the result of the log function, which means y value change the sign. So let's see. G of x log 2 negative x, I said it is a reflection over y-axis, and then h of x is reflection over x-axis. The graph is like this. So do you see that? G of x, it was the log function was here this way, right? But now when you put the negative in the x, it became this way, which means it reflected over this line, y-axis, which is x equal to 0. The shape, it was like this. Now look at this. Still vertical asymptote is same, right? X equal to 0. It's a reflection over y-axis. So when you have a negative inside the parentheses here. But now h of x, this, originally the graph was like this. Oh, so negative became positive and positive became negative because you multiply negative to the log function. So this we say reflection over x-axis. Remember this? So you understand this, right? Then let's think about this. You have original function f of x is equal to log 2 in the parentheses a minus 2x. So remember, what is the most important thing when we draw the log function? Is we find out vertical asymptote, right? How do you find out vertical asymptote? Can you think about it? So we set a minus 2x equal to 0, right? And solve for x. Before, when the parenthesis has only x alone, it was x equal to 0, the vertical line, y-axis was the vertical asymptote. But this is like a translation. So let's see. So how do you solve the vertical asymptote? You set a minus 2x in the parentheses equal to 0 and solve for x. Then move 8 to other side, and the negative 2, you divide by negative 2 both sides. So x equal to 4. So do you see here, right? The vertical asymptote is x equal to 4. It's translated. It was x equal to 0 before original one, but it translated from here to here. Now, let's see briefly how to put into the calculator to draw the graph in detail. So I'll go to the meta calculator and you choose the graphing calculator. And in the function, I write down in the equation here. Equation was 8 minus 2x, 8 minus 2x. We'll go to the numerator, right? This go to the numerator. And then base is 2, denominator is over log 2. Go down to the here. You enter it. Now your graph looks like this. Now I'll zoom in. So, oops, I go backward so you can see better. Now you can adjust your graph with this plus and minus. Then you can see your vertical asymptote here x equal to 4, right? But even though it looks like it's touching here, but just remember it never touch. So keep going down until y becomes negative infinity when x goes to the 4, right? So we want to find the coordinates. So I said we need to find go to the table. Look at the table here and create the table. And mostly it's in the negative values. So not the positive, everything is x positive, mostly what? Not available, right? So let's see from negative about 20. Start from negative 20. Then what we do is only we figure out, I want to see, so negative 20 give you which one is integers. So here, y equal to 5, x equal to negative 12. You find only the integer values. So x equal to negative 12, y equal to 5. Next one is negative 4, y equal to 4. And x equal to 0, y equal to 3. And I want to more. So let's go from 1. Then, x equal 2, y equal 2. X is 3, y is 1. And then when x is 4, it is a vertical asymptote. So you plot all these integer values on the plane, then make sure when you draw the graph, as we did here, like this, it never touch this vertical asymptote. So this way we can draw the graph. So make sure you put the both arrows on the end of this graph. So it means it keeps going, continue to the infinity. So when x goes to the negative infinity, y goes to the positive infinity, it keeps growing. But when x goes to 4, it never passes 4, but y goes down to the negative infinity. That's the end behavior. So like this. So let's check for your understanding here. So one more time, when you draw the graph, first, make sure vertical asymptote. You know how to find the vertical asymptote, right? A minus 2x equal to 0 and solve for x. So did I use the same interval? For exponential function, we can change the y intervals, like y scale, we can change it for y values. But log function, y goes by 1 is opposite because it's inverse function. So x change the, you change the scale for x. So for this case, it was not necessary actually. But some, if you think you need it, so you can change the scale of x. And did I plot each point properly, only integer values, and put the arrows on both ends, and make sure you don't touch the vertical asymptote. So if you look at your packet, you will see a few questions. Please finish and hand in through email, please. So we are done here.